Good morning. Welcome to the video on real numbers. It's for CBSE class 10th and we are going to solve today exercise 1.1. So the questions and the screenshots which are taken for solving questions are taken from NCERT CBSE, which is an open and free source ebooks, and I am declaring clearly that it is used only for academic purpose. So any credit for creating these pictures or of the content goes to the original creator. Yes, in this particular chapter, first we will be studying about this theorem 1.1, which is given in the book, and that is called fundamental theorem of arithmetic. So fundamental theorem of arithmetic says that every composite number can be expressed or factorized as a product of primes, and this factorization is unique. Yes, of course, the order of the prime factors, it may differ. It's not necessary that the factors should be kept in an ascending order or in descending order. It may be in any order, that doesn't matter. Okay, we know that all the prime numbers, which are prime numbers? Prime numbers are those numbers which are having its factor 1 and self. Other than these prime numbers, all numbers are composite numbers. Composite numbers. So all composite numbers are expressed as product of primes. And we will be finding highest common factor and lowest common multiple. So in highest common factor is product of the smallest power of each common prime factor. Smallest power of each common prime factors, whereas lowest common multiple is the product of greatest power of each prime factor. Okay, greatest power of each prime factor involved in the numbers. Let us solve the questions. So in question number 1, it is given that each number which is given here, we have to express it as product of its prime factors. So product of its prime factors. So question number 1 is given 140. Let me solve this one for all your understanding. So 140, we know that 140 can be divided by 2 very well, because 0 is the last digit. As per the rule of divisibility, it can be divided by 2, it can be divided by 5 also. Okay, so 2 if we are dividing, we get 70 here. Then again with 2 we are dividing, then we get 35. Yes, now 35 will be divided by 5 and we will get 7 here. So 140 can be expressed as a product of prime numbers 2 into 2 into 5 into 7, which can be written as 2 square into 5 into 7. Right? Okay. Similarly, 156. So 156 if we are dividing, so we can see that 6, 5, 11, 112. It is also divisible by 2, no doubt. 2 7 ja 14, 2 8 ja 16, and then 2 3 ja 6, 2 9 ja 18. Again it is not divisible by 2, it can be divided by 3. So 3 1 ja 3, 3 3 ja 9. All have become prime number. So we will keep on dividing till the time we will get all prime numbers. So 2 into 2 into 3 into 13. And this can be written as 2 square into 3 into 13. Right. Similarly, we can solve for 3825, which can be written as, you have to do 5 into 5 into 3 into 3 into 17. Okay, which can be written as 5 square into 3 square into 17. You see that I have written 3 later on and 5 first. So it doesn't matter. The order doesn't matter. Then fourth one, 5005 can be written as 5 into 7 into 11 into 13. Okay, similarly fifth one, that is 7429, will be written as 17 into 19 into 23. Okay, so in this way we can write for question number 1. Let us go for solving question number 2. Question number 2. So it is given that find the LCM and HCF. We need to find LCM and HCF, and also we have to verify that LCM into HCF is equal to product of the two numbers. Okay. So first one we will do 26 and 91 we are given. We have to find LCM. So first let us express it as product of primes. So 26 means 2 into 13 and 91 it means 7 into 13, right? Okay, 91 is 7 into 13. Now LCM, if we are going for LCM, so LCM here the power 13 common factor is there, so 13 will be as it is. Okay, so common factor 13 will come here, greatest power is also 1 only. Okay, now remaining factor 7 into 2, so 2 into 7, this also will get multiplied and you will be getting 182. Okay, LCM. HCF, highest common factor, so 13 is the highest one, so common factor 13 is the highest common factor HCF. Similarly, second one, 510 and 92. So 510 we can express it as 2 into 3 into 5 into 17. Okay, and 92 we can write that 2 into 2 into 23. Now the common factor, this 2, so HCF is equal to 2, and other it is not common. But LCM, so common factor from 2 it will come, then again 3 into 2 into 5 into 17 into 23. Okay, that will become common. So this will be giving us as 23460 after multiplication. Okay, right. Now third one, that is 336 and 54. So 336 can be written as 2 into 2 again into 2 into 2 into 3 into 7. So we can write it as 2 to the power 4 into 3 into 7. Okay, then 54. So 2 into 3 into 3 into 3. Okay, so HCF will be here, 1 is there, so 1 we will take it from here, so 2 into, then another 3 is there, 3 is there, so common, so we will take it as 6 as HCF. Okay, now LCM, so LCM will be 2 common, so 2 will be there. Okay, again 2 to the power cube also will come here, then 1 3 is common, so that we will take, then another 2 3s are there, that also will come here, and into 7 will be coming. Okay, right. So that will be the LCM. So we can say that 2 to the power 4 16, into 27 into 7, and this is 3024 will be the LCM. Right? Yes. Let us go to question number 3. Verify it was there. So we can see that for verification we got for first one, like for this one we got HCF, it was 13, LCM we got 182. If we will multiply LCM into HCF, okay, so with multiplication just we can do it LCM into HCF, that is 13 into 182. So we can multiply, no problem, that is 13 2 ja 26, then 13 8 ja 104 plus 2 106, 10 13 1 ja 10 and plus 10 23. So 2366 we have got. Okay. Similarly, if we will be multiplying 26 and 91, 26 into 91, which we can write 26 into 100 minus 9. So 2600 minus 9 6 ja 54, 5, 9 2 ja 18, 5, 23. So this will be giving us 10 minus 4, 6, then 9 minus 3, 6, 5 minus 2, 3 and 2, 3, 6, 6. See, both of them are same. So in this way we can verify for all. Now question number 3, again we need to find LCM and HCF. Here 3 numbers are there, process is same, there is nothing difference. Earlier 2 numbers were there, here 3 numbers will be there. So 12 we can write it as 2 into 2 into 3, and 15 we can write as 3 into 5, 21 we can write as 3 into 7. So here we can see 1333, so HCF will become 3. Okay, LCM will be 3 into 2 into 2 into 5 into 7, and this will be giving us as 420. Okay, second 17, 23 and 29, in this case all are already prime number. Okay, so 17 is 7 into 1, 23, 23 into 1, 29, 29 into 1, so only HCF will be equal to 1. LCM will be multiplication of all, 17 into 23 into 29, and due to that multiplication we will be getting 1139. 339. Okay. Third one. So third one is 8, 9, 25. 8 is 2 cube, 9 is 3 square, 25 is 5 square. Nothing is common here. So HCF will be equal to 1. LCM also will be equal to 2 cube, 3 square into 5 square. So just 8 into 9 into 25. 25 is 200 into 9, 1800. Okay. So this is there. Moving to next one. Okay. We are given that HCF of Question number 4. HCF of 306 and 657 is given as 9. We need to find LCM of 306 and 657. We know that LCM into HCF. We are already knowing the formula HCF into LCM is equal to product of two numbers. So this formula we will be utilizing it. So here product of two numbers divided by HCF. So this will be equal to 306 into 657 divided by 9. So 9, 3 are 27, 36, 4 are 36. So 34 into 657 will be giving to us as 22338. Okay, right. Question number 5. Check whether 6n, 6 to the power n, can end with the digit 0 for any natural number n. So we see that 10, if suppose 10 is there, we know that 0 will have 10. So it is 2 into 5. It means the number should be divisible with 2 also, divisible with 5 also. But in 6 to the power n, we will not get 5 at any cost. Okay, 5 will not be coming. Always the number will be having even number only at the end. So in that case, the number, no number will be divisible by 6. 6n will not be divisible by 5. Will not be divisible by 5 in any case. It is divisible by 2, yes, but it is not divisible by 5. Therefore, there will not be any, it will not end with the digit 0. 6 to the power n will not end with the digit 0 anywhere. This was question number 5. Now question number 6. Given that this and this are composite numbers, how we will prove? So we can write 7 into 11 into 13 plus 13 can be written as 7 into 11 into 13 we can take as common, and okay, 7 into 11 into 13, so plus 13. Are composite numbers. Okay, so we can take 1 plus 1 here. So this will be giving us as 7 into 11 into 13 into 2. Now this is expressed as all the prime numbers are there. All the prime numbers are there, that's why it will be a composite number. Composite numbers. Okay. Similarly, 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Okay. So 7 into 6 into 4 into 3 into 2 into 1, and then into 5 we can take 1 plus 1. So this will be 7 into 6 can be written as 2 into 3, 4 can be written as 2 into 2, into 3 into 2, into 1, into 5 into 2. So a composite number can be expressed as product of all prime numbers, so all prime numbers came. So that's why we can say that these are composite numbers. Question number 7. It is given that there is a circular path around a sports field, and Sonia takes 18 minutes to drive one round of the field and Ravi takes 12 minutes for the same. They both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again? So in this type of cases, we are meeting again at the same point after how many minutes? In that case, we need to find LCM. LCM of 18 and 12. So we know that 18 can be expressed as 2 into 3 into 3 and 12 can be expressed as 2 into 2 into 3. Okay, so what will be LCM? LCM will be from these two common, so 1 2 will come, from 1 3 will be coming, okay, and again 2 into 3, and this will be giving to us as 36. So after 36 minutes, okay, both will meet. At the starting point. So like this we solved the questions related to real numbers, exercise 1.1, and I hope that all our students would have understood, got clarity for solving questions related to these real numbers and especially on LCM and HCF, finding out LCM and HCF. If you have liked the video, kindly share with your friends. Thank you very much.